All right, college algebra kids. Today's video is a lecture video on absolute value inequalities. So I'll be going over kind of the key of absolute value inequalities and doing 3 examples. So let's go ahead and get started. So I'm going to start off with probably the important part that you need to realize and remember. And it is 2 key things. Is that with inequalities, remember you have less than or equal to, greater than or equal to. Those are your 4 potential inequalities. Well, how absolute value inequalities work is that there is, when you're given a specific situation, there is a equivalency result in terms of your answer. So what I'm going to do is that I'm doing, for example problems, I'm doing 15, 16, 17. I'm not going to do 18 because 18 is going to be part of the homework that I will assign to you. So what I'm going to do is that in the space for 18, I'm going to write these key these key notes, and then as I do the examples, you will see where they come into play. So here is keynote number 1. Okay. When you have absolute value of whatever your expression is, and it is greater than or equal to a constant. So this means greater than a constant or greater than or equal to a constant. Then you can write, so this is equivalent to ax plus b is less than or equal to negative c, or ax plus b is greater than or equal to c. Okay. So when you have absolute value is greater than a constant or absolute value is greater than or equal to a constant, you can split it into, kind of like with absolute value equations, you can split it into 2 cases, a positive case and a negative case, where the positive case is ax plus b is greater than or equal to c. Negative case is ax plus b is less than or equal to negative c. All right. Now, there are 2 problems I'm going to do that relate to this specific rule. So I'm going to do those 2 examples. And then once I have completed that, then I will show the other rule. So looking at number 16. Okay, we're going to start with 16 here. Focusing on this problem. 4x plus 8 is greater than 40. So this follows the rule of ax plus b greater than or equal to c. Okay, so that means I can rewrite this as absolute value of 4x plus 8 is less than negative 40, or 4x plus 8 is greater than 40. So that's just straight up following from the rule. So now I have to solve the inequality. And since I am solving the inequality and I'm following a rule, you don't need to split into 2 cases. With inequalities, you don't need to split into 2 cases. That's only with equations. With inequalities, whatever you're given, you're given, and you work with it. So solving each one individually, okay? And so I'm going to put it over here on the side, and then I'll erase later. So the first one is absolute value of 4x plus 8. Actually, I don't need the absolute value anymore because I'm solving this. So I'll just restart. So 4x plus 8 less than negative 40. So we subtract 8. 4x less than negative 48. Divide by 4. Divide by 4. We get x is less than negative 12. So for this one here, I'm going to put it up here. X is less than negative 12. Okay, so that is from solving the first inequality. Okay, so then solving the second one, I'm just going to erase this, and then I'm going to solve the second inequality. Okay, and to note the difference, I'm doing it in a different color. 4x plus 8 is greater than 40. Again, I subtract 8. I get 4x is greater than 32. Divide by 4. I get x is greater than 8. So I have x is less than negative 12 or x is greater than 8. So whenever you finish solving inequalities, you have to graph it. Okay, so how we graph it is they give us the number line, so we're going to graph on the number line. So I'm going to do the graphing in a different color so you can see how that works. So x less than negative 12 is going to be everything less than negative 12. So here's negative 12. And since it is less than or equal to, this is an open circle. So let me make sure that I do this justice. So less than negative 12, this is an open circle. And then everything to the left of this is a solution. Okay, so when it's less than or greater than, it is an open circle. And then when it's less than or equal to or greater than or equal to, because of the equal to, it is a closed circle. And then we have x greater than 8. So here is 8. It's an open circle. And then everything to the right is an answer. And there is how you solve an inequality and how you graph its solution. Okay? So again, you start off by looking at the rule and then just literally copying what the rule says and applying it to the correct inequality that you are given. So in this case, this was greater than, so I applied the rule that I just wrote down to this problem, solve each inequality individually. Then once I get my answers, I graph it on the number line. So we'll just go ahead and dive into 17. 17, I won't go into as much detail, but I will follow the rule and I will solve accordingly. So here we'll go back to blue. So this is absolute value of negative 2x plus 8 is greater than 6. Because this is a greater than inequality, I'm still following this rule. And so I'm going to have negative 2x plus 8 is going to be less than negative 6. That's from the first part of the rule. And then I'm also going to have negative 2x plus 8 is going to be greater than 6. So talking through this, for both inequalities, you're going to subtract 8 from both sides and then divide by negative 2. Okay? Now, remember that with inequalities, when you divide by a negative, you have to flip the sign. So what I'm going to do is that hopefully you have this rule copied down, because I'm now going to erase it and show you what I mean in showing the steps for these two problems. So adios, rule number 1. Thank you for your help. All right. So we're going to do this in a different color. So looking at the first one, okay, when I subtract 8, I'm going to get negative 2x is less than negative 14. And then when I divide everything by negative 2, because I'm dividing by a negative, the sign switches. I'm going to get x greater than 7. Looking at the second inequality that I have to solve, when I subtract 8 from both sides, I get negative 2x is greater than negative 2. And then when I when I divide by negative 2, I flip the sign, and that's going to give me x is less than 1. And so there's a key thing here. It is the or that goes with this rule. So it's x greater than 7 or x less than 1. So going to the number line, when I plot this, x greater than 7, so 7 is here, open circle. To the right, everything to the right is an answer. X less than 1, open circle. Everything to the left is an answer. So there are two examples related to solving inequalities where the inequality is absolute value is greater than or absolute value is greater than or equal to. When your inequality is greater than or less than, it is an open circle. When your inequality is greater than or equal to or less than or equal to, it is a closed circle. So both of those examples pertain to that rule number 1. So I'm going to clear this up, and now we're going to talk about rule number 2, and I'll be doing number 15 as an example. So we're going to go back to blue. All right. Rule number 2 says that if I have the absolute value of an expression and it is less than or equal to a constant, then that is equivalent to the following setup. Negative c less than or equal to ax plus b less than or equal to c. What we have here is what you call a compound inequality. When you have everything together, you have inequality, you have utilizing the absolute value expression, and you have negative constant, positive constant. This is a compound inequality. And so this one is a little bit nicer in the sense that you don't have to do two separate workouts, in the sense of you have one workout inequality problem, you have another workout inequality problem, you get your two separate inequalities in the graph. Here, you get to kind of do a 2-for-1. You get to kill two birds with one stone. You get to do all of the work at the same time, and the inequality will be shown all together, wrapped up in a nice little bow. So the previous rule is known as the OR inequality, okay? Here, this is known as the AND inequality. And maybe you kind of piece together already why this is, but after I do example question 15 as an example, I'll kind of explain why this is what it is. So looking at example or question 15, we have absolute value of negative 9 plus 9m is less than or equal to 27. So this is a less than or equal to, so we're going to follow the rule. So we're going to set it up as such. Negative 27 is less than or equal to negative 9 plus 9m, which is less than or equal to 27. And so this is a compound inequality, so I get to do all of the operations at the same time. What I mean by that is if I am going to, I need to move the negative 9 because I want to solve for m. I need to move the negative 9 to the other side. Well, in this case, it's going to be the side where I have a negative 27 and the side where it has a positive 27. So I'm going to add a 9 to the left and to the right. And so now when I rewrite this next line, I have negative 18 less than or equal to 9m less than or equal to 36. And now to solve for m, I divide everything by 9. So that means I divide to the left and I divide to the right. And so I have negative 2 less than or equal to m less than or equal to 4. And there you go. You know what you're going to graph. You're going to graph everything between -2 and 4. So going to your number line, -2 is here. It is less than or equal to, so I'm going to have a closed circle. And then I'm going to go all the way till I get to 4. And then 4, I'm going to put another closed circle. And then here, in between these two numbers, is where my solutions are for this inequality. So maybe you've made the connection, maybe you've realized something, but with the or inequality, you had answers going in opposite directions. You had x greater than a number, so it was going to the right. You had x less than a number, it was going to the left, but they were going in opposite directions. They were never going to touch at all. That is what the or inequality does. Answers go in opposite directions. The and inequality says it has to be in between two numbers. There is a boundary between two numbers where my solutions are going to fit. That is the and inequality. Okay? So that is solving absolute value inequalities. There are two rules you are responsible for, the or rule and the and rule. Or refers to when your inequality is greater than or equal to, and refers to the inequality where it is less than or equal to. Again, you can go back to anywhere within this lecture video to recap any rule that you missed or anything you need to just double check on. But other than that, that is today's video. Make sure you have these notes written in. Make sure you come with questions. I will be doing other examples not related to your homework. Okay, I will announce what the homework is next time you come to class. But be aware that for absolute value inequalities, you don't need to split into two cases. You just follow the two rules that I listed here in this video. Best of luck to y'all, and I'll talk to you next time.